Right. Yes, I am recording it. So we're now recording. Great. Oh dear, that was a good call. Good call. Right, share screen. Where are we? There we go. So yeah, so I'll just step through the code so this is obviously the code that I've used for Chopper. One thing that I've mentioned before is that you can't really sort of just take all of the sketches and all of the code to the Maestro, copy it across, and then expect it to work on your builds. And the reason for that is that the upper and lower limits of servos, the hardware differs a little bit. Some of the angles will differ a little bit. So really, if you're going to start to do servo-based animation, what you've got to do really is kind of build it from the bottom up in the animations, and that's what we've gone through in the past. You know, you create the kind of the animation scripts, if you like, making sure that you've got the right angles for each ones. So really, it's far better doing that than trying to copy what is a very, very complex bunch of things, because you've got some code that's running on the Maestro, you've got some code that's running on the Arduino, and you've got a bunch of servos. If you do that, it doesn't work, or it goes out of different angles, it'll create sort of problems. So it's better sort of building it from the sketch, from the bottom up, hence we wanted to sort of go through these sessions. So I won't go through the Padawan code, because I think we've gone through this on a couple of occasions, and Steve's done some great videos on this. But what I want to do is just point out a couple of things where some of the codes you've got to insert to get the communication working. The first bit is kind of around the libraries, and in particular the serial port. So what the Maestro, how we communicate with the Maestro is via serial. And again, depending how familiar, you've got a transmit and you've got a receive line, and that's exactly what they do. So if you just connect the transmit from the Arduino to the receive on the Maestro, it will receive commands, which means it will start to do something. But what you won't be able to do is get any status or any feedback. If you connect the transmit from the Maestro, so going the other way, to the receive on the Arduino, you can send commands back. So we're using serial connections. There's two types of serial connections on the Arduino. There's a hardware serial connection and a software serial connection. So one of the limits of the Arduino Uno is you've only got one hardware serial connection, and that one hardware serial connection is shared with the USB port that you use to upload the code. So it's a bit of a gotcha in that if you've got anything that uses the default serial port on the Uno, it will only ever work if you've not got the USB connector connected. So it's caught me out a few times when I first started, because I've been trying to run and diagnose code from the laptop with the USB connector in, and then that is just basically disabling the hardware serial port on the Uno. So really, for what we do, for some of the more complex builds, really recommend that you use the Arduino Mega. And what the Arduino Mega is, it's got a number of serial ports that you can use. So the default serial port for the USB connection, you can run, and then you can have different serial ports to connect hardware. And they are built into the hardware, and therefore when you reference them in the code, you just give it the serial and the number of the serial port that you're using. So the alternative is to use software serial, which is a little bit of code that runs on the Arduino that creates a sort of a pretend or virtual serial port, and you connect that to certain pins, and the default pins tend to be 10 and 11. Now, the drawback of software serial port is, one, it's software, so it does take a bit of processing power for the Arduino. But the second one is it uses what are called interrupts, and I don't want to get sort of too technical, but what interrupts are is it's a way of stopping the Arduino and giving it something of a much higher priority to do. Now, why that's a problem is there's other bits of software that also use interrupts that can get conflicted. And the software serial port, one of the main, I guess, known faults that sits around that, or conflicts, is a software serial code conflicts with the servo library. So if you're running the servo library and you want to start to use that to control servos, and you're running software serial, you'll see lots of twitching on the serial on the servos. Hence, to keep it as clean as possible, I tend to try and use hardware serial. Now, what I've done with Chopper is I have used software serial, basically because on a Padawan we've got the siren that controls the dome, which takes a serial port. We've got the saber tooth, which controls the motors, which takes up a serial port. So we're already using a couple of serial ports. And so what we want to try and do really is okay, so then we can use a third serial port, which is free, which I've used to control the body. And then I wanted a fourth serial port to keep it clean, which is to control the dome, hence I've used software serial. What I did do then is I used the servo library to try and control the nod of the head, and that's where I got interference. So I used a different sort of solution to that. But I thought it's just worth talking through that serial thing, because otherwise you may get all sorts of glitches and things that you're not quite sure is why things are happening. So what we've got here is a bunch of code that is just setting up the serial ports. So the first one is including the Padawan Maestro library. So as we covered last time, the library is effectively like a software driver for Arduino. And then we've got an include the software serial code. And what we're doing here is this is literally just telling the software serial which ports to use and what to call it. So it's saying software serial, I'm going to call the virtual port Maestro serial, and I'm going to connect pins 10 and 11 with the second pin number that you put on there being the transmit pin. And again, that's really, really important, because the transmit pin is what makes the magic happen. That's what runs the animation. The receive pin is more around where it will actually where you'll get feedback. So pin 11 goes from the Maestro, goes from the Arduino on pin 11 into the receive, the RX on the Maestro. It can get a little bit confusing on TX and RX, but don't worry about it. If you're not sure you've got it connected the right way around, you can just swap them over. You're not going to do any damage to it. It's only data that's going back and forth. The second one that I've got here then, so what I'm doing here is this is linking the particular type of Maestro. So there's a micro Maestro and a mini Maestro. We're using mini Maestros, and it's saying what we're going to do is we're going to create something called a Maestro. We're going to link it to serial 3, and we know it's a mini. And then the second one, we're going to call it Maestro head, and we're going to link that to the software serial port that we've created. Does that sort of make sense? Cool. Stop. Any thoughts, questions, observations, or humorous comments at this point?
Yeah. So part of the problem is all these serial ports taking up all this overhead, right? Has anybody thought about, you have your main thing with your Padawan system, and then you have maybe another Arduino that can act as like a serial port hub, so to speak. So you just use one port out of the main system, and then assign like a device ID to tell the next one what you want to address and send.
Yep, you can do that, Phil. So I mean, ultimately the Arduinos are really flexible in how they all connect together. There's the I2C, which is a different type of port that lets you assign addresses and effectively is like a bus, so you can put multiple devices on there. So you can connect two Arduinos together with either the I2C bus or with serial, and then have the second one as a serial hub. That's possible. The reason I didn't do it is, one, we're stretching further and further away from the original Padawan code, so it becomes harder and harder to support. And secondly, what I'm really conscious of is keeping the closest, fastest control that I can do on the motors for a 200-pound droid or whatever these can be when they start to be made out of metal rolling around. What I don't want to do is have anything that interferes with the foot drives. Things like animations and even the dome spinning, I'm not as concerned about, but I would tend to try and keep the foot drives at least on the standard serial. But you can get very creative in the way that you want to sort of extend those communications if you want to. But what it does mean is it means a lot more customization on the code and start writing your own sketches.
Makes sense.
Yeah, that all makes sense. So yeah, so this is the challenge you've got is there's no red lights and green lights that say, hey, we connected the serial port up correctly, or oh, boo, we haven't connected it up correctly. So this is where you kind of have to just have at least a bit of a kind of an understanding on how these things work. So let me just pull up there we go, share this. So yeah, this just gives you a bit more of a kind of a picture on how we connect it. So you've got the RX and you've got the TX, and you've got pin 11 that you can see goes to the RX. So pin 11 kicks data out and it's received into the Maestro. Pin 10 gets information back from the Maestro. So this is your connectors. The other kind of gotchas on here is making sure that you've got both sets of power to the Maestro. We did cover this last time, but the Maestro requires 2 power supplies. It requires a servo power, which powers the servos, and it requires a logic power that powers the actual logic of the Maestro. Now, if you're running 5 volt for your servos and your Maestro, there's a little jumper pin that you can move across that effectively will let you run both off that servo power. But what you've got to do is make sure that you've got both power to the logic and you've got power to the servos. If you power the logic and don't power the servos won't move, but it'll chat away all day long. And if you don't power the logic, but you power the servos, effectively it's dead. It's just sat there waiting for it to be powered up. So it's a little bit of a kind of something you've got to play with. And of course, when you plug the USB connectors in, what you're doing is powering the logic through the USB connectors. So things will work when you first plug them in to play with them, and then when you sort of start switching cables around, or you want it to run independently with just the Maestro control, it can get a little bit confusing. Okay, so hopefully so what we've got in here, just a bunch of things, loads of Maestro, loads of serial ports, and attaches the serial ports to these objects. These objects here, you could type anything you want in here. You could call them Fred. It really doesn't matter. I've called mine Maestro, which is the body, and Maestro head, which is for the head. What I probably should have done is put Maestro body because it's a bit more user-friendly, if you like, but these are your labels that you've created for those specific objects. And that's pretty much then the first part of the Maestro actually set up. So at that stage, all your software is loaded, and then you've just got to make sure physically that you've got your connections in place. And the physical connections, the diagram that I just showed on the software serial will be how you connect that software serial. How you connect to serial 3 is through the actual hardware serial ports, which you might be able to see just on here. So on this Arduino Mega, I don't know if you can see under communication sections there, you've got TX3, RX3, TX2, RX2, TX1, RX1. That's your 3 serial hardware connections. So where I've called something serial 3, that's where it will have actually, where you connect it to TX3, transmit 3, and RX3.
Michael, you got a TX0 and RX0 as well, don't you, for the sound there? Pin 0 and 1 right next to communicate, right above communication. I'm trying to chase the board around as you're moving it. So yeah. you got 0 and 1 are TX0 and and RX0 as well, right?
That's right. Yeah.
That's where the sound goes with, I believe.
On the Padawan, it could be, yeah, it could be. As I said, I've not got the. I've not. I can double check in the code actually. Let me just have a quick look. Yeah, you have got the. So I've got Sabertooth on serial 1, serial 2, serial 1 begin, serial 2 begin, serial 3. No, I've just got the. I've only got 3 serials and a software serial.
Okay.
Oh no, sorry, there's another one. While serial. No, that serial 0, I think, is used for the default serial port.
Okay.
Which
I thought that I wasn't sure where the MP3 trigger hit.
Yeah, it's good. It's a good question. What does it say? Let me just have a quick look on the Padawan website. Yeah, the MP3 trigger is a bit of a. It's one of the interesting ones. Let me have a quick look. RX to. Let me just stop sharing that. I'll just. Sorry,
did not mean to derail the conversation. I apologize.
No, it's worth looking at it because it's. It says here, so connect the following pins from the MP3 trigger to the body of the Arduino. So you've got RX on the MP3 trigger, which is the receive, which is connecting to pin 1 on the Uno.
Which is the TX on the.
Which is the TX on the Mega, isn't it?
Yeah.
It must use the built-in hardware port, but it doesn't. When I'm looking through the code, it doesn't actually start the serial. So it may be something that's actually in the library for the MP3 trigger.
Okay.
Well, yeah, you're right. Let me just. There we go. So I'll just pop back into the code. Yeah. So when just going through the code. What you normally see is where it starts all the serial ports.
At the begin.
At the beginning, which we've seen there, but we don't see. We see there's a Sabertooth where it's using serial port 1 and serial port 2 for the drive and the dome. But there's nothing that specifically loads the serial for the sound. And then if you look at where it's actually starting the serials, which is here, it's only starting serial 1, 2, and 3. So what I think's happening is the library that you've got for the trigger is automatically almost connected to pin 1.
Okay.
Because all it's doing is it's loading the trigger up and then it's just setting some volume down there. So I can't see anything in there that specifically does it. But you're right, it is connected to that default one. I do tend to keep away from the default serial just because I know that it's one that the USB actually uses.
Gotcha.
But yeah, so, but as I say, I mean, I'd stick to the standard Padawan build, and then all we've really done to add the Maestro is add those extra serial ports. Okay, so moving on. So what we've done is loaded and started the serial ports and linked them to the right devices. The next kind of bit of code that we've started to put in here sits in setup. So there's 3 chunks in the Arduino. The first chunk is kind of what's called global almost, which is code that runs everywhere. And then you've got a couple of standard little sets of code. The first one being setup. This just runs once and effectively is there to set up the devices that you've got running. So in setup, the first bit of code that I've added into here is these 2 lines. So the first line is serial 3.begin and then the baud rate. So in And this again, this is where you've got a bit of a gotcha. It's not just on what we're doing here, but also with the Sabertooth, is serial has to be set at a baud rate. So you can set 9600, 19200. You can go higher and faster and higher. The default for the Maestro is 9600. If the advantage of using a higher speed serial port is the software runs a little bit quicker. However, you risk getting more noise on the serial port and therefore it doing kind of unexpected things. So I do tend to stick with the default, and the default is 9600. So all this is doing is it's starting serial 3, which is my body at 9600, and then it's starting the software serial, which is the Maestro serial at 9600. So at that point, then we've got kind of comms that's coming out there, and then as we scroll down, there's a little bit here, which I think relates to because this is looking at the default serial port. So that may be something to do with what you mentioned before around the sound. Or it could actually be the USB driver, because it says it's checking the USB connection. But again, this is all part of the standard Padawan build. And then we move into the section which is the loop. So what the loop is, I think we mentioned this last time. The loop is just the code that just keeps running. So this is where effectively, once you've fired it up and everything's booted up, this is the one that just continues loops around. So in here, at this stage, we've loaded the drivers, we've attached the drivers to the serial port, and we've started the serial port. So effectively, everything's running, and all we're waiting to do now is to send commands to it to get it to do various animations and whatnot. And I think we did cover this off a little bit last time, but you can, as you go through it, you can see it becomes, and it's quite well noted as well, so you can see what Dan's actually started to do with the code. So this one's about starting to blink the lights. This is how you enable or disable the drive. And so you can kind of scroll through these. All I've really done when it comes to the animations is I've started to then inject some code on some of the buttons, so that I put a little note there that says it's a Maestro animation section. So all the rest is fairly standard, and again you can read through it. But what this section does is it's got these couple of if statements. So all the if statements do is they check something. So it's just checking the Xbox controller, it's getting the button that's pressed, and it's checking to see if R2, and if you're familiar with games, that's the button at the back, the trigger. Yep, Scott, that's it. If you can do that sign again, that'll trigger something. That's the one. Yeah. So if that's pressed and held in,
sorry.
I know that's what I was doing. We did it together. It was great. If that's pressed and held in, then it's checking again to see if the up button's pressed. So that's what I've used there is a combo key effectively. So what I do is press and hold that button, and then press the up button. If that combo key is used, what it's going to do is it's going to then use a restart script, which means it just starts the script from a zero. So it starts the script from the beginning, and it's running script 0. And then effectively, if you just scroll through that section, you can see how I'm calling different scripts. So if the R2 is pressed and I use down, it runs a different script. If that R2 is pressed and it used left, it runs a different script, etc., etc., etc. So you can pretty much, if you wanted to do, completely rejig all of the different buttons on the Padawan just by changing the button press, the if statements in the code. Or what you can do is kind of look for where you've got free buttons. I did this back on when I was doing the animations for the original V2 R2D2, and I found that the R2 button isn't really used. So what I tended to use is the R2 button with the up, down, left, right as kind of the main core to kick animations off. And then likewise the L2 button, which is the other side, I use that. So on Chopper now I've got one side, if I press the right hand button and then do the up, down, left, right, it'll do body animations. If I press the other side, it'll do the left button, it'll do head animations. But again, you can configure this however you want to play with it. Does that make sense so far? Cool. The other thing, and I think we spoke about this last time, the other thing that you can add into there is also then sound. So if you wanted to do the arms coming out and flexing, or you wanted, you know, on the R2 for various animations or panels to open and for him to squeal, you can literally just underneath that add another bit of code that triggers one of the sounds. And again, if you don't need to be effectively a code wizard to be able to do that, all you really do is look down, find some of the code later on, which is fairly easy to see. So this is where the sound is triggered based on some buttons, and the code is MP3 trigger dot play, and then the actual track number that you want to play. So that's track 8, track 2, track 9, etc., etc. And sometimes you can choose to have these played randomly or whatever. So once you can literally nick that code if you wanted to, and you can inject that code then with the, you know, copy and paste in there. And if you were to do that, then what happens is when you press the R2 and the right button, it will kick the Maestro script off, and it will also kick the sound off. And this is a real.
Michael, if you did something, if you've got the both transmit and receive going out to the Maestro, how would you code? Say if you wanted the Maestro routine to go first, once that routine is done, then trigger the. Is there a way for the Maestro to tell the Arduino, okay, now do the sound?
There is. So again, if I just open examples, let me just have a look. So under the Maestro and the script, let me just see if it shows you anything in here. So there's, in the library that comes with the Maestro, there is the reverse of that, which is where you can check statuses. I'm just trying to find out where we've got, if there's anything, might be on input. Let's look at input. It's the one here. Yeah, there you go. So it's in the, if you hit the Polu website and the Maestro website, there's a bunch of different commands that you can use that will get you feedback. And one of those commands is to check that if a script is running on the Maestro. So what you could do is you could get it to, again, it would take a little bit of coding, but you'd effectively run the animation and set a state to say that the animation is running. So you'd set a variable, which is animation running equals 1 or something like that. And if that animation is running, you can use these feedback commands to get feedback to tell you when that script is finished. So it's this is just an example of one of the things that lets you get information back if you've got the track transmit and the reset. So what this does is this is setting a something called.
We're still on the Padawan chopper code on your screen.
Oh, sorry. That would be why I'm just waffling on. Let me just input. There we go. Share that. Can you see that now? Yeah. So this is so again, if you go on to File Examples and you look on the Padawan Maestro, there's one called Input, and this is the input code. And what input is where you're then using, so you're not using the transmit from the Arduino to throw commands out. You're actually wanting to pull information that tells you the status of the Maestro. So what this particular bit of code is doing, I'll just go flip down to the loop, is it's actually getting the Maestro dot get position for a servo number. So in this case, this might be 0. So what it will do is it will read what position that servo is at. So if you've got it running through an animation where it's slowly moving or it's going left and right, you can read positions. But there's a whole bunch of code in the documentation for Maestro that lets you check to see if the script is running, if it's in error. You know, there's a bunch of things, so you can read the status of it. So to do what you mentioned, Scott, there's kind of a rough way, which is what you could do is effectively run the animation and run a slight timer, and then after a second and a half, which you've worked out that the animation roughly runs, it will then run a sound. But that's not getting any feedback from the Maestro. The other way you could do it is you could then get it to run the animation, set it to a state that's saying it's running an animation, and then in the background, just get it to check to see if that script has stopped. When the script has stopped, then play the sound. So that's a couple of different ways of sort of doing that. As I said, you're probably getting into more of the advanced side of stuff, but it's more pointers of where to look and to play. Rather than going through that sort of stuff step by step.
Right. Again, sorry for derailing.
No, I mean the whole point of these sessions is just to chat through, because we learn stuff by kind of going through different thoughts and different examples. This is a challenge, is like Phil said about using one of the Arduinos as a hub. These things you can ultimately expand them to however you want to, and you can write code to do whatever you want to do. But there isn't sort of a standard way of doing that. But if you've got the pointers on where you can find the information, then you can have a little bit of a play. And obviously, the more you learn about this and the more you build your own code, then much easier does it become when you want to start to do fault finding and whatnot.
Certainly. Thank you, Michael.
Cool. So yeah, this is very, very basic. All you do is capturing a button press and then triggering an animation. There is, so on the chopper code that I'm using at the moment, one of the, it's not so much a bug, but something that could easily be enhanced, is it doesn't check to see if the script is running. And what the Maestro does is once you start off another script, it just completely stops what it's doing and then starts what you've told it to do. And so what that means is, for me, it's a discipline really of, I just make sure that everything's stopped before I kick another animation off. However, if what it is possible to do is for me to kick something off on Chopper, is periscope arm will come up, it'll move around, it'll shine a light, and if I was then to kick an animation where he flexed his arms, the periscope would just stay there with the light on. So I've interrupted one animation, it stayed where it is, and then it's flicked over to another script. So what probably the better discipline would be is where you've got these restart scripts, is before that you just make a check to see if there's any other script that's running on there. Because that way, if there's a script running, it says, no, you can't start your next animation until you've run that script. And it depends, again, how you want to code it for your build. I quite like it this way because it does give me the flexibility to override if I want to, I'm not waiting and thinking, actually, I could have done a different animation. But as long as you understand how it works, you can do both of them. Does that make sense? Yeah.
So far.
Good. And to be fair, I mean that pretty much is it. That from adding the code into the Padawan and getting the Padawan running, that's all you've really got to do. So the three main steps are, you just got to make sure everything's set up and everything's communicating. The second one then is assigning the serial ports and the objects. So you've loaded your libraries, you've assigned your serial ports and objects, and then really it's just grabbing button presses and linking those button presses then to animations that you want to run. Okay.
Okay.
So what I thought we'd probably just spend last 10-15 minutes or so is just talking through I guess some of the easier ways to fault find. One of the one of the guys on the forum mentioned that he'd got it all up and running and working, but he just got the error light on all the time, and nothing was actually firing up. So it's how do you sort of fault find and check to see what's actually going on. So what I thought I'd do is just step through the default script and just show how that actually works, because I think if you want to fault find the first layer, there's three things that can probably go wrong with this system. The first one is where you've got a script issue or a script error. The second one is where, so you could have a script issue or coding error. The second one is power, where you've either not powered up the servos, you've not powered up the Maestros, you've not powered up the Arduinos. And then the third one is communication. So your serial connections aren't connected or whatever. So they're probably, to me, the three main areas. And the way you problem solve that is you just start to, first of all, build your system up pretty much from scratch, and make sure that, for example, that you can get basic movement out of it before you start to add some of the more advanced stuff. I just want to flick the camera over, if you bear with us. I'm limited in USB ports on this laptop, so I need a USB hub really. So there we go. Ooh, you can see. So hopefully you can kind of see that. So what I've got here is I've got an Arduino, I've got the Maestro, I've got a separate battery supply, and I've got a servo. And what I'll do is I'm just going to connect the Maestro board up through USB. That's connected, and then I'm going to also connect the Arduino board up as well. Okay. So what I've got connected on here, which probably can't see too much light, quite a little bit. I've got these two connections here, which are for the serial ports. So that's your serial plus and minus. I've got the power, serial transmit and receive. I've got the power on, I'm rubbish cameraman. Power and ground on there, and they're connected to the relevant ones on here. So what this is running at the moment is the default script. So just show you what I'm running. There we go. So again, if you're looking to build these, just first of all get yourself a Mega, get yourself a Maestro, and connect them together and sort of familiarize yourself how it actually runs. Now, the default, when you first go into this, so if you go file and examples, we've covered this before, but every bit of hardware tends to come with its own script examples to save you having to write the code, because you can just steal the ones that they provide with it. And the one that I'm looking at the moment is under Padawan Maestro, and it's just called script. Really simple script that allowed you to check all of the things that I mentioned previously. So the first thing, I'll just scroll through the script. So what the script gives you, first of all, is it actually gives you code for the Maestro. So I don't know if you can see that where I'm sharing on that, but what you've got from line 26, if you read through the notes, it says the Maestro has to have this script installed on it. So it's got from 26 Maestro script for the example, right the way through to line 52, which is, so this bunch of code here. Yeah. So I can control and see that, I can copy that, And then what I'll do here is I'll just go into the Maestro software, which I've got shared there. Let's share, there's a Maestro. There we go. Share. Yeah. So this is the Maestro code. Sorry, this is the Maestro software that comes to the Maestro. Just connect it because we're on USB. And then if I go into the script area, what I can do is I can just paste that script that was in the Arduino sketch into here, and it's in the Maestro language. And then if I hit apply settings, what it actually does is it uploads that script. Does that make sense?
Yeah.
Yeah. So you've got a bunch of code that's effectively allows you to run an example script. What we're doing with the Maestro is we're running code on the Maestro and we're running code on the Arduino. So what they've done is they've included the Maestro code in there. Now there's a couple of interesting ones on here. So the first thing that I've noticed with this is at the beginning here, it has this little thing which says begin repeat, and it says don't do anything by default. And what I think that is it's when you first power it up or it starts to run the script right from the beginning, all it really does is it just runs through a loop which is begin repeat, begin repeat, begin repeat. Now, when you do a script, as we did do previously, where we went through creating a sequence and then we uploaded the sequence into the script, it doesn't do that begin repeat in there. What I've noticed is when you first then try to start to run the, I've got it on my chopper actually, but when you start to run those subroutines, you end up getting the error light on the Maestro and it says buffer overrun. But everything still works. You can still call the scripts off. The animation still works, but the error light's there. And I think the reason the error light's there is I've not got a begin repeat. I've not got anything at the beginning that just kind of goes through. So there's a interesting one just on the examples. And again, it's worth sort of experimenting that because it may just turn the error light off. The error light's just a red light. It doesn't really seem to affect the running of it. But I think what it's trying to do is run code in the background, which is more for if you was having something that was running by default. So all I've done is I've pasted the code in here. As I said last time, you hit apply setting, it then loads the code to the Maestro. And then if we go back into the script. So what I've done is loaded that code. My next stage then is to look at the code. Really, really simple. What it's doing is it's doing exactly what you saw in the chopper, including Maestro. And then it's got this bit of a statement at the beginning which says, if the serial port hardware is open, define Maestro serial port hardware open, else use software. So the way I'm interpreting this is it's kind of checking to see if there is a hardware serial port available to use. Other than that, it'll use a software serial port. Now, I've had all sorts of problems with this. So if I do a sketch upload to the, there we go. Right. So I've just uploaded that code. And I've stopped the script on the Maestro. So that code is now running on the Arduino, but the servo has stopped. You can see. So at the moment, there doesn't seem to be any communication between the two on that serial port. So what I think the code's probably a little bit too clever for its own good. What it's doing is it's first of all checking to see which serial port is open, and then it's using that first serial port. But that means that I'm going to end up chasing around with the cables to try and work out which serial ports it's chosen to use. So this statement, which you'll see in the example, I think is kind of creates a bit of confusion. So what I've done is I've taken all of that logic out, just doing the 2 forward slashes. You could just delete it if you wanted to make it really simple. And then what I'm doing is I'm using include software serial port and calling that serial port the Maestro pins 10, 11. So I'm forcing it to use software serial. I could force it to use hardware serial just by, when we get onto this second section here, using serial 3 rather than Maestro serial. So and again, I you know, there's probably cleverer programmers than I am, but it's just a little bit of a gotcha that this selection here seems to create no end of problem. So so a couple of changes I've made here is I've took out that logic just to force it to use software serial ports on 10 and 11, and then I've switched it over to the Mini Maestro. And then if I do sketch upload, I don't know if you can see the serial.
I can hear them though.
You can hear it, yeah. So the servo is now starting to run again. Does that make sense? Yeah. So yes. So as I said, it's just something to watch when you get onto that script. And I think the guy that was having some problems with the error light, he was getting the error light coming on and no movement. So I'm wondering whether what he's done is he's kept this auto selection, and he's actually got, it's more of a communication error that he's actually ended up getting. So I'd recommend, when we're doing diagnostics, just to make sure all your connections are made correctly. Load up the example switch, just connect your cables up to your Maestro, and effectively run the example switch. Take that first bit of logic out, connect your serial ports up to pins 10 and 11, and see if that runs. If that script's running, then it means that you've got power to the Maestro, it means you've got logic power to the Maestro, and it means your communication's up and running and working. The other useful things that you can do if you've got the two connected, i.e. you've got both the Arduino and the Maestro connected via USB, is you can actually still connect to the Maestro while the script is running from the Arduino. And so if you look on the script page here, it will show you, I don't know if you can see if it's coming up on your screen, but there's a little red triangle that drops under each of the code as it steps through.
Yeah.
So if I hit stop scripts, I'm physically stopping the script on the Maestro. What happens is the Arduino then starts it again. So this stage, I know now that whilst I'm telling it to stop, I know that we've got comms up and running and working. I'm also getting no errors on here, which was what I got previously. I kept getting these overflow errors, which I'm fairly convinced is that first bit of making sure that it's got nothing to do by default, and it only calls each of those subroutines when they need to. The other thing just on here as well, if you go into serial settings, this is where your 9600 is set. So you can, again, if you're not getting any communication, you can quickly check onto there to see that they make sure that that's set to 9600, that your serial port's connected. But this is honestly just when you're first playing with these things, just go step by step. Get your Arduino up and running and working. Connect your serial ports up. Make sure you've got power going to both of them. Get just one servo on there and get it up and running and working. Because once you've got it up and running and working, you've got the confidence that you know what you're doing, and then you can start to get onto the more complex stuff that you're starting to build around your particular droids. Cool. And I think that pretty much covers everything so far on the Padawan and the Maestro. There's obviously a whole bunch of different things that you can do on the coding, on some of the more advanced bits of code, getting feedback and all that sort of stuff. But hopefully that's enough for everyone to have a little play around and to get started.
So Michael, just wanted to confirm something. So in this system with the Padawan, you basically need 5 serial ports, is that right? One for the siren, one for the saber tooth, one for the MP3 trigger, and then you have a Maestro in the head and Maestro in the body.
That's how I'm running it, yes.
So 5 ports.
5 ports. And the reason I'm hesitant is, firstly, the MP3 seems to use a port within the library, so I can't see anything in the code that specifically says it's a serial port, but it is using serial 0, as Scott said. The other reason
I'm pretty sure I got that from Steve's videos of the MP3 plugs into serial this. So
it definitely uses 0, or definitely uses
1.
A serial port. I don't know which ones in particular, but it definitely uses a serial port.
So it does do. The other reason I'm hesitant, Trevor, is that you can do a piggyback another Maestro off another Maestro. So in theory, you can run them in serial, so to speak. So you'd only use one serial port, and then you can send commands through. And again, I mean, I tend to keep it quite simple in Chopper, that I've got, one serial port for this, one serial port for that, but there are other configurations that will help to reduce the number of serial ports needed.
Right.
If that makes sense.
It does.
Cool. Jeff, that's an amazing balancing act you've got with the cat there.
He jumps all around. It's my son's cat. Just have one last question on this. Trevor, I went ahead and did what you said, which was replace his libraries, and now I get a strip was not declared in the scope. So I gotta go through some more. I copied his two libraries from Andrews into the Arduino, or the Adafruit NeoPixel library, and yeah, that's what I get now. Strip was not declared. Do you know, was it designed to run with a specific version of the library? Well, I guess it doesn't matter because you're replacing it anyway. Huh.
Yeah, I'll have to dive into your, post some pictures or some your code or whatever, and
I will.
We can help you out.
All right, thank you, Trevor.
I basically just copied his stuff over, changed the port that I was using, and then it worked. So
all worked, yeah.
Okay.
Welcome to the land of Arduinos.
Yes.
Yeah.
Remember, guys, this is a hobby. This is what we do to relax. Yeah. So, anything else on the Padawans or the Maestros? Are we all okay? Cool with that? Good. Yeah. Whilst this do, we have a play with them. If we want to put one of these sessions together at a bit of a later date, in a good few weeks when everybody's managed to blow things up, set things on fire, or otherwise had great fun, we can go through kind of trying a bit of a problem solving if people hit brick walls. But I think this probably gives us enough to get started.
For sure.
Have I missed? You haven't uploaded.
Get us in trouble.
You haven't uploaded the nod instructions yet, right?
No, I haven't.
Okay.
There's tiny bits. There's a video overview of Chopper which shows you how all of the nod stuff goes together and things. The bits I've got to do yet, I've got to cut the main gear, which is literally 2 minutes of job. I've just had a interesting weekend where I've been ferrying the family around everywhere. I was going to try and get done this weekend. And then I've got the instructions for the nod, and then Chopper's pretty much done. What I'm trying to do in the background then is the bigger prints for the body. Everybody who's got a big printer wants big prints for the body, and everybody who's got a small printer wants things cut up. So just got to go through those two little bits. But and then there is some more modelling to do for the bread pan arms. So when they open at the moment, they're just 2 empty spaces, whereas I want to put a couple of utility arms in there, but effectively the main build's pretty much done now.
Single print body, that's what we want.
Single print body?
I couldn't wait. I just went ahead and printed. I just couldn't wait for the single print. So
no, the Chopper works really well on the multi prints because of the angles. And again, some of the club files when the first ones were all quite straight and angular, so they're a little bit easier. But when you start to look at the real Lucas mesh for it, it's all at different angles. Everything's out. The 2 eyes are slightly out. The whole thing is just kind of a bucket of pieces. So printing it in little bits is a lot easier than trying to get a support for something that overhangs that's got a little bit of an angle as well. But what I've done is I've got the core body done now. And there's a couple of guys that are kind of looking at the fusion at the moment to see if they want to they want to rush ahead and do a single body. So I said, here, there you go, have a look at it, and fingers crossed something will come out of that. But actually, I quite enjoy building the multi-part ones. And I've got a S5 as well. It's just the nervousness, isn't it, of running a 1 week print.
Well, I know
Michael,
you're. Go ahead.
Oh, sorry. I have a question. Have you heard anybody having problems with the dome ring print? Or is it just my machine? I've printed 3 of these now, and what's happening is when it gets to the area where it's just printing the teeth, my machine starts printing in thin air. I re-downloaded the file, spliced it in Cura, spliced it in Simplify, and I don't know if I'm never around when it actually quits.
Okay.
So I have a heat cartridge or something like that that's crapping out at 20 some hours, or what? But I'm having.
No, I'm not. I tell you what I've had on my S5 though is I've had breaks in the cable which only affect at certain heights. So what mine was doing was it was switching off the cooling fan when it got to about 25 mil or something stupid, because it only started to break the cable when it got to that angle. And it drove me absolutely bananas, because I'd get heat creep and then it'd end up just backing up and seizing up. So I know that your cable can break, so it affects at different sort of angles. But I've not had any issues with the. I mean, I think I probably only printed the gear mesh once. I'm just gonna open the gear mesh just to see what it looks like in the slicer.
I was just curious if anybody else had ran into it, because I've changed retraction settings. I've changed my heat. I've tried different profiles, and no matter what I do, it's stopping at the same spot. So I'm starting to think it's my machine.
That's the dome gear, isn't it?
Yeah.
Oh, it's also upside down. Not bad of me.
That may be. That's what I was going to say. Are you sure did you line it on the build plate right?
Yeah.
Okay.
So I even went ahead and to see if it was the file, I sunk it down in the build plate in the slicer, so it would only print the teeth that protruded, and that printed fine.
Okay.
I could print the section past this, but I can't print them all in one piece for whatever reason.
So that's the piece you're talking about, isn't it?
Mm-hmm.
So yeah, obviously the file's upside down. I just realised that, so I need to. Let me just export. Save that now. There we go. Right, yeah. So the file's now the right way up. So what you're saying, Tim, is it prints this bit will print, will it? How far up does it go?
So it goes until you get to. It'll do all the top layers for this piece, and then when it just starts to do the teeth themselves, that's when it quits.
Right. So that's. I don't know if you can see the screen, but that's where you started to.
Right. Yeah. Right around there.
Yeah. Did you get any teeth?
Nope. One of them I got.
So just
almost
flat.
one. Yeah, I got almost one layer of the teeth on this one.
Right. Now there's nothing I can see on the mesh that would cause it to do that. So I would think if there's anything else that on the machine. Yes, it's one of those you really want to see it, don't you, to see what your machine's doing when it happens.
Yeah, but it seems to always happen if I'm wrapped up with something and I come back and it's printed a 1/4 inch into the air before I got back to it.
And what states the filament at that point then? Is it nozzle jammed?
Yep.
So it's not feeding the filament.
No, and then the weird thing is when I turn the machine up, if I preheat the nozzle and just give it a little poke and a shove, it'll go ahead and out the end of the nozzle.
Huh.
I wonder, well, it's one or two things. It is either heat creep, which just literally watch, how do you do that? Yeah, if you heat the nozzle up so that your cooling fan comes on, you can move the axis up and down and wobble the cable, and just make sure that that the heat fan isn't switching off, which is a break in the cable. Have you replaced the cables at all on your S5?
I have not, but it hasn't had very much use.
Okay.
I've always been very nervous about running 2 rolls of filament on like a 6-day print.
Yeah. It's worth having a little play around with the cable just to make sure you've not got a break in the cable. The other thing is that make sure there's no lifts in the underneath if there's any warping at all, or if it's lifting off the print plate. What can happen is if you're not getting complete bed adherence, it lifts up, but then when it's actually doing the flat area is pushing against the nozzle because of the lift, and it causes a nozzle block. So sometimes layer adherence can cause that.
Well, I got the BL Touch. I think I'm pretty good on that aspect because the failed part with purple glue stick, I've had to pretty much, even after the bed cools, really chisel it off the bed to get it to break loose. So I don't think it's lifting, but that doesn't mean it's not actually, the part is wobbled on the bed either.
Yeah. It's only, to me, those are the two main things that I've hit in the past. One is heat creep because of some weird electrical connection, or even the connector that goes to the nozzle, so the nozzle cools down. The software is not great at detecting that sometimes, so the nozzle can cool down a little bit, and then it can cause a bit of a block. And then what happens is the extruder gear wears through the cable a little bit, so it can't restart again when it hits the heat.
Tim, can you print another file that's the height of that? Does that print okay?
That was my next thing I was going to do.
Yeah.
I was going to shrink the overall file to a quarter size X and Y and still have the same height. So it's only like a 2-hour print, and then run it and see what happens.
I can do you also.
The problem with that test though is that you won't be running it. It won't have been running for the same amount of time.
Right.
If it is heat creep.
Right. Same distance, same diameter.
Duration to heat it up.
Yeah, if you're getting heat creep, once you get to that height, you notice once you get to just the teeth, you're getting a lot of retractions. And so you could be pulling, check your retraction length. You could be pulling outside. If you don't have the Bowden tube tight to the nozzle, you'll get a gap there and you could be getting a clog.
Well, since it's not a overall cosmetic part, maybe I'll just turn retraction off for the print, and who cares about stringing, because not much of it's going to be seen anyways.
Yeah.
And maybe I can give that a go.
With a sandpaper or whatever, can't you?
Yeah. Lots and lots of sanding on PLA Plus.
No kidding.
So just I'll try that, or just try printing all the teeth. Make sure you can print all the teeth.
I can do you I can cut you a small section out at full scale if that helps, Tim. If you want to just run, you know, kind of about an eighth of the, a small eighth of the dome, so you can just see how that runs, because then you'll at least be able to watch it at that height.
Okay, I appreciate that, Michael.
I'll find out. I can do that now, actually. All right, split body. Yeah, I'll print that out now, and I'll cut that out, and then I'll ping you a link across the file, so you can just give it a whirl.
Thank you, sir.
So yeah, okay, guys. I think we're done. But if you got any questions, sorry, Anne. Oh, is that just a bye? That was a bye while dog bark in the back.
That was a bye.
That was a bye. Cool. Okay. Yeah. So any questions? ping him across. More than happy to help as it starts to go through. I think the Padawan chopper sketch is obviously in the share anyway to look at, and again it'll work for R2s or for your amazing build, Scott, as well, which I don't even know what it's called, but it looks good. So yeah,
Robbie,
of course. That's all.
Yeah.
Cool. Fab.
Hey,
Okay.
Michael, real quick question. How did you run your the linkage on the arms? How did you run your what did you use? Was it monofilament to do the
Okay.
the
I use 1.75 mil nylon filament.
Okay.
So yeah, the nylon. I use nylon filament for all of the cable control stuff because it's stupidly strong, and it's quite smooth as well. So it works really well.
Great.
Obviously, don't use normal filament; it'll just break in after the first 2 or 3 goes. But the nylon stuff is superb.
I've actually used a couple of strands of fishing line. I'm attempting to use that.
Going to look at doing.
Yeah.
Yeah. That'd work as well. I've not played with. I think people talked about either piano wire or whatever as well also, but the nylon stuff works really well for me. Okay. Yeah. Yeah, that's it.
Hook up the servos, and then we'll be good to go.
Cool.
Yeah, it does take quite a bit of shifting that, hence we use a little bit of the stronger servos. But so as with everything, trying to fit all of the mechanics in a tiny space is never that easy.
And those were about $20-some a piece. But you know what? You just do this as you go along. You don't pay attention to how much money is going out each week. just buy it. Michael says you need it. You got to just buy it.
You don't. There's lots of other hobbies that I think smoking's probably more expensive marginally, but that's about
In
it.
the long run.
Yeah, exactly.
Right.
That's kind of where you get these people
Michael.
off, don't you, and which things are, and you think, Christ, it'll take you 12 months anyway, so you won't notice by the end of it.
It can definitely be very expensive.
It can indeed. It can. But everybody needs a hobby. Right, guys, anyway, take care. Lovely to see you all, and I'll catch you in a bit. Bye.
All right, Michael, thank you. Good night, guys.